Having labeled the circuit diagrams with arbitrary symbols, the final task is to derive the Boolean expression for this circuit diagram. So let's start with symbols from left and work our way to the final output, which is F1 and F2. So to begin, we have T1, which is equal to A and B and C, and we have T2, which is equal to A or B or C. We also have G1, G2, and G3. So G1 is A and B, G2 is uh, A and C, and G3 is B and C. On the next layer, or next level, we have F2, which is equal to G1 or G2 or G3. Then on the next layer, we have F2 prime, then which is just simply equal to this prime. So G1 or G2 or G3 prime. Okay. Next is we have T3, which is equal to T2 and F2 prime. Finally, we have F1, which is equal to T1 or T3. And now let's work on deriving the Boolean expression using the input variables. So let's start with F2. Its shorter is here. So you have here F2 is equal to G1 or G2 or G3, and G1, G2, G3 are AB, AC, and BC. So your F2 is simply equal to AB or AC or BC. Hmm, That. Now we're done with F2. Let's work on solving for F1. So for F1, here it's T1 or T3. T1 is ABC here. T3, however, is T2 and F2 prime. F2 prime is this, and F2 is this one. So let's derive F2 prime based on these inputs. So F2 prime is equal to A prime or B prime and A prime or C prime and B prime or C prime. So we have to simplify this and come up with a standard form for this expression. So to do that, let's label this with X, Y, Z. That. So it will then mean that F2 prime is equal to X and Y and Z. So let's start with X and Y. Let's simplify these two expressions. So let's take that and distribute it. Distributive property of Boolean algebra. So you have A prime and A prime, or A prime and C prime, or B prime and A prime, or B prime and C prime. So we will have this expression, and based on Boolean identity, x and x is simply x. So for this variables a prime and a prime is simply a prime. Then we will have our final expression for that is a prime or a prime c prime, a prime b prime, or b prime c prime. So there we have xy. So these two, we simplified this and then we join it with z. So your f2 prime now is equal to x, y, z, which is equal to, this is your xy, and this is your z. So it's just a matter of algebraic manipulation or distributive property, a prime, b prime, or a prime, c prime. Then if you will continue that, so you will be able to get um, this expression. So a prime, this, and b prime, a prime, and c. This one a prime and c. A prime, c prime, b. So a prime, c prime, b prime, and a prime, c prime, c prime. So this one. Okay. Next is a prime, b prime, b dot, and b prime, c prime, c prime. So b prime, b prime, c prime. Again, based on Boolean algebra or Boolean identity, variable which exists, the same variable exists in the same expression, it's just equal to that variable. So c prime is equal to c prime. So after simplifying that, f2 prime will become a prime b prime, a prime b prime c prime, this one. This is just a b prime, and then this is b prime c prime. This one is a prime c prime, and a prime c prime, and a prime b prime c prime, and b prime c. Again, based on Boolean identity, x or x is equal to x. So that means we can remove remove one of the two the same expression. For example, a prime b prime here, you have another one here, so this one will be removed. That's redundant. A prime b prime c prime, this one, b prime c prime is here, and a prime c prime is here. So we have eliminated the similar expressions. So f2 prime is going to be this. So this is the simplified expression for f2 prime. So from this expression, we have this final expression. So going back, so T3 is f2 prime, which is this one, and T2. So what is T2? That's A or B or C. Okay. So T3 is equal to this expression and this expression. Okay. So you distribute that. So the same thing that we did earlier. So distribute A prime B prime to A prime B prime to B, B prime A prime B prime to C. So if you keep doing that, your final output will be T3 is equal to this expression. So again, based on Boolean identity, uh, the existence of prime and unprime is equal to 0. So x and x prime is 0, and 0 and any variable is equal to 0. So if prime and unprime variable exist in the same expression, then that entire expression will be equal to 0. So this one is equal to 0. A prime is 0. A prime is also 0. B prime is also 0. B prime is 0. B prime is 0. That one retained. This one C prime. C and C prime. C and C prime. So what's left is A B prime C prime, A prime B C prime, and A prime B prime C. So T3 will be equal to those remaining expression, and since F1 is T1 or T3, so this is your T3. F1 is now equal to this expression or T1. So that's the Boolean expression for output F1.